Today we are talking about alicyclic hydrocarbons. Alicyclic hydrocarbons. What is alicyclic hydrocarbon? Now before we talk about that, let me talk about hydrocarbons again. A hydrocarbon is an organic compound that contains only carbon and hydrogen. So just like the name suggests, hydrocarbon, this is for hydrogen and this is for carbon. So hydrocarbon, it consists of carbon and hydrogen only. Something like CH4, something like C2H6. There's only hydrogen atom and carbon atom here. There's only hydrogen atom and carbon atom here. So because of that, these two compounds are hydrocarbon. Okay, now look at this one. Look at this slide. Now this one, carbon and hydrogen atom, nothing else. So they are all hydrocarbons. But when we look at this one, we have oxygen atom here present. So because of the oxygen atom present here, it is no longer a hydrocarbon. This one also has oxygen atom attached to it. So because of the oxygen atom, it is no longer a hydrocarbon. So these two are not hydrocarbons because of the oxygen atom attached to it. But these ones only carbon and hydrogen, so they are hydrocarbon. These ones are not a hydrocarbon. So any organic compound that has only carbon and hydrogen is a hydrocarbon, but anyone that contains any other thing apart from carbon and hydrogen is not a hydrocarbon. Okay, so this hydrocarbon is actually made up of two groups. We have aliphatic hydrocarbon and we have cyclic hydrocarbon. What is aliphatic hydrocarbon and what is cyclic hydrocarbon? Aliphatic hydrocarbon is a hydrocarbon that has straight chain or branch chain structure. For instance, when we draw something like a carbon skeleton like this in a straight chain, it is an aliphatic hydrocarbon. Aliphatic hydrocarbon because the chain is straight. Also, when we draw a branch chain hydrocarbon, maybe this one go this way and maybe this one also go this way. So this branch chain hydrocarbon is also aliphatic hydrocarbon. So any hydrocarbon that has a straight chain or branch chain structure is called an aliphatic hydrocarbon. But when we have something that has a ring structure or a closed structure, we call it a cyclic hydrocarbon. Take for instance, if you have something like this one, it has 4 atoms, 1 2 3 4, and all the 4 carbon atoms, they are joined together, they are closed. So anyone that has a closed chain like this is called a cyclic hydrocarbon. Another example, if you have another one that has like 5, this close to this joined to this joined to this, and this joined to this finally. So this one has a closed structure, so because of that, this one is a cyclic hydrocarbon. So no matter the number of carbon involved or no matter how the shape looks, Once everything come together to form a ring or a closed structure, it is called a cyclic hydrocarbon. But if the chain is a straight chain or just a branched chain, it is called an aliphatic hydrocarbon. So that's the difference between aliphatic hydrocarbon and the cyclic hydrocarbon. Our compound of interest is cyclic hydrocarbon. So the cyclic hydrocarbon again is divided into two groups. We have alicyclic hydrocarbon and we have aromatic hydrocarbon. Alicyclic hydrocarbon and aromatic hydrocarbon. These are the two groups of cyclic hydrocarbons that we have. Which one is alicyclic hydrocarbon and which one is aromatic hydrocarbon? How do we know them? Alicyclic hydrocarbon, it is the kind of hydrocarbon that does not have alternating double bonds. A cyclic hydrocarbon that does not have alternating double bond. Take for instance this compound here, alicyclic hydrocarbon. This one has alternating double bond. You can see this is a double bond. There's no double, this is a double bond here. Now there's no double bond this side. There's another double bond here. There's no double bond here. There's another double bond here. So because of this one is aromatic cyclic hydrocarbon. But this one, it does not have the alternating double bonds. So it is called alicyclic hydrocarbon. So the one with alternating double bonds is called aromatic hydrocarbon, while the one without alternating double bond is called alicyclic hydrocarbon. Now the alicyclic hydrocarbon, this one, alicyclic hydrocarbon, there is no alternating double bond, while this one there is alternating double bond. Something like when we draw our benzene. If we draw our benzene, of course we always draw something like this. Okay, so it has alternating double bonds. Therefore this one, that is benzene, is an aromatic hydrocarbon or aromatic cyclic hydrocarbon. But when we draw a structure like this, a structure that resembles a benzene, it resembles a benzene. Okay, if we draw a structure that resembles a benzene like this, but there's no alternating double bonds inside it, it is called alicyclic hydrocarbon. Okay, so this alicyclic hydrocarbon is what we're actually discussing. So we look in details what alicyclic hydrocarbon is. Alicyclic hydrocarbon, it has three forms or three groups. We have the one with only single bond here, single bond here, single bond here, single bond. Everything about it is single bond. Now we have another one that has a double bond. See a double bond here. Then we have another one with a triple bond here. Now take note, look at this one that has double bond. You see that there's no double bond this side and there's no double bond this side, so it is not alternating. No double bond here and no double bond here, so it is not alternating. Because of that, it is still alicyclic hydrocarbon and not aromatic hydrocarbon. But if the double bond is alternating, then we say that this one is aromatic hydrocarbon. Okay, so these are the three alicyclic hydrocarbon groups that we have. Now the one with single bond, this one that has only single bond, is called cycloalkanes. Now the ones with a double bond, it is called cycloalkane, while the one with a triple bond is called cycloalkanes. Cycloalkane, cycloalkane, and cycloalkanes. Okay. Okay. So this is it. This is cycloalkane, the one that has single bond all through. Now this has double bond and this has triple bond. Okay, cycloalkane, and cycloalkane. Okay, now we talk about cycloalkane. Cycloalkanes, they have the general formula CnH2n. CnH2n. This means that for every carbon atom in the hydrocarbon, in this cycloalkane, there are 2 times hydrogen atom present in the same hydrocarbon or the same cycloalkane. Okay, so this is the general formula for it. So if you put 1 here, it should be 2 times 1 of hydrogen. If you put 2 here, it should be 2 times 2. If you put 3 here, it should be 2 times 3. Okay, so these cycloalkanes, the smallest member of it is cyclopropane. That is 3. Because of what? If we put 1 here, this one will be 2. Only 1 carbon cannot close itself. Now if you put 2, now it will be like carbon and carbon, and these 2 carbons cannot close themselves. So it is only like when we have 3. When we now have something like 3 carbons, we have like 1, 2, 3. Then we can join this one and join this one, and then this one will join like this. So only this can form a closed system. So this is the shortest member of it, or the smallest member of a cycloalkane, the one with a 3 carbon, which we call cyclopropane. Okay, so from cyclopropane we have cyclobutane, cyclopentane, cyclohexane, and so on and so forth. Now how do we name this cycloalkane? The nomenclature. In naming a cycloalkane, we take the carbon ring as the parent name. The parent name is the functional group. So when we have a structure like this, like this one, okay, to name this ring should be the functional group. This should be the parent name. So I know that in naming any organic compound, the substituent should come before the parent name. So this one is now a substituent. This methyl group is a substituent. So we have to name it first before we now put the parent name. So the correct name for this compound is methyl cyclohexane. Why hexane? Because we have 6 ring structure here. That is, it has 6 carbon atom in the ring structure. We have something like 1, 2, 3, 4, 5, 6. So, and hex is 6. Now why N? N because it is under cycloalkane. So it has only one single bond all through. Single bond, 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 single bond. So it would be wrong for any person to say that the name of this is a cyclohexamethane or any other thing you name it. So this one is wrong. This is the correct form for it. So you should not name this ring before you name the substituents. Okay? So that is it. Okay. So another thing, that is number one thing in naming a cycloalkane. Then number two thing, if there is only one substituent attached to the ring need not be numbered. Just like this example again. Okay, or let me go to this. Okay, now we have only one methyl group attached to it. We have only one methyl group attached to it. So because of one substituent, only one substituent, there's no other substituent. So there's no need for us to start numbering the carbon, saying 1, 2, 3 to determine the position of this methyl group. There's no need for that. So we just put it as methyl cyclohexane. If you write 1 methyl cyclohexane, trying to give position for the methyl group, you may not get it correctly. Some people may not give you the right mark for this. So don't just bother to number it if it has only one substituent. So the correct name is what? Methyl cyclohexane, not 1 methyl cyclohexane. Now, if it has two substituents, how do we name it? If it has two substituents, if two or more substituents are involved, number them alphabetically and follow the shortest direction to the second group. What do I mean by this? Look at this. This one has two substituents. This is a T group. This is a T group. And this is methyl group. Ethyl E and this one methyl M starting it. I will say we should number them alphabetically. So in alphabet, E comes before M. So in putting the name of this in, we first of all write these substituents. Now before we write this methyl substituents. So we start with this one, the E, and name the carbon there as carbon number 1. So the ethyl group has carbon number 1. And then we take the shortest direction to the second one. We can go this way. We can say 1, and say 2, and say 3, and say 4, and say 5. But this is a long journey. So once we name this one, we find the first position. Now 1. Then we look for the shortest position. Now 2, and then 3. So that is how to number it. So the correct name for this structure is what? 1 ethyl 1, because the ethyl is attached to carbon number 1. 1 ethyl 3 methyl, because the methyl is attached to carbon number 3. It's attached to carbon number 3. So 3 methyl cyclohexane. Why hexane? Because it has 6 carbon atoms in the ring. We have 1, we have 1, we have 2, we have 3, we have 4, we have 5, and we have 6. So the correct name is 1 ethyl 3 methyl cyclohexane. So any other way you name it is not correct. If you name it 1 ethyl, if you start going this direction, 1, 2, 3, 4, 5. So you see that you are taking the long journey, the long direction, so you will not name it correctly. So if you say it is 1-ethyl 5-methylcyclohexane, you failed it. If you say that it is 3-ethyl 1-methylcyclohexane or any other thing you can name it, you failed it. Okay. So this is the assignment we have. So copy this and try to name them. Name these structures. This one has one substituent. So I've given you the tip how to know it, how to name it. Now this has two substituents. To name it, you begin with the one that is, you name it alphabetically. Which one comes first in the alphabet? This one is methyl and this one is what? Ethyl. So you start from the one that comes first in the alphabet and name it. Then you check the total number of carbon in the ring. That will determine whether it is propane, butane, pentane, hexane, or any other thing. So the same thing with this one, you name it properly and submit. So next time